Dear students, in one of the previous videos, I have derived the formula for sum of infinite geometric series. Now in this video, I will be solving some examples on that formula. But before going further, if you didn't subscribe this channel, so subscribe it. Let's go. The infinite geometric series is written as a1 plus a1r plus a1r square and so on. And the general term is a1r n minus 1, and then the series is continued. In this series, this r is common ratio which is multiplied with a1 to get a1r, and this r is again multiplied with this a1r to get a1r square, which is the third term, and so on. So each next term is obtained by multiplying the previous term with the common ratio, and the sum of this series is obtained by this whole series, infinite series, is obtained by a1 divided by 1 minus r. Let's do some examples. The first example is given. The geometric series is given in sigma notation, and this geometric series is infinite geometric series because k is starting from 1 and till infinity. If we expand this series, then we will first put k is equal to 1, then 2, and then 3, and so on. And we will be getting 7 0.1 power 1 minus 1 plus, then putting k is equal to 2 in this, so 2 minus 1 plus, then put k is equal to 3, so 3 minus 1, and so on. And 7 0.1 power 0 plus 7 0.1 power 1, 7 0.1 power 2, and so on. Again simplifying, 7 into 0.1 plus 7 into 0.01, and so on. And 7 plus 0.7 plus 0.07, and so on. So this is the series. You may be given this series instead of sigma notation. Both of these series, that is sigma notation and this one, these are same. So if you are given this series, which I have obtained from this sigma notation, so the first term is 7 and r is obtained by dividing the second term by first term, which is 0.1, and then third term divided by second term, which is 0.1. So r is 0.1. The first term is 7 and r is 0.1, so S infinity is a1 divided by 1 minus r. Putting the values, first term is 7 and divided by 1 minus 0.1, which is r. 0.1 is r. So 7 divided by 0.9, and the answer is 70 divided by 9. So this is the way. But looking at this sigma notation without expanding, we can calculate a1 and r from this. Looking at this place, if here we find k minus 1, then, so this is the condition. If here we are finding k minus 1, then this is a1, which is first term, and under this power, what is this? 0.1. So this is r. So a1 is 7 and r is 0.1. And again putting these two values in this formula to find the sum of the infinite geometric series. So 70 by 9, this is the sum of this whole series up to infinity. Let's move further. This is the second example. Find the sum of infinite geometric series. This 125 plus 25 plus 5 plus 1 plus 1 divided by 5 plus so on. So the first term is 125, and r is obtained by dividing the second term by first term, which is 25 divided by 125, and the answer is 1 over 5. And third term is divided by second term, so 5 divided by 25, and the answer is 1 over 5. Both the answers are same, so r is 1 over 5. Putting these values of a1 and r in the formula, S infinity is equal to A1 divided by 1 minus R. A1 is what? 125, and divided by 1 minus R. R is 1 by 5, so 125 divided by 4 over 5, and 5 multiply 125 divided by 4, and the answer is 625 divided by 4. So sum of this whole infinite geometric series is 625 divided by 4. If we find the sigma notation of this series, then that is what? First of all, we will find the nth term, a1 r power n minus 1. An is equal to a1 is 125 and r is what? 1 over 5 power n minus 1. So this is the nth term, and this series is written in sigma notation as k from 1 to infinity and 125 1 over 5 power k minus 1. So this is the series. And again, if we are given this whole series, this one, in sigma notation like this, so this will be a1, and under k minus 1 this is r. So again, a1 and r are here, and we will put these values in this formula, and we will get the sum of this whole infinite geometric series. But again, the nth term can be a bit changed, like 5 power 3 is 125 and 1 over 5 power n minus 1. So the answer is 5 power 3 and multiply 1 over 5 power n minus 1 and 5 power 3 minus n minus 1 and 5 power 3 minus n plus 1, so 4 minus n. So this is the nth term, and this series in sigma notation can be written if we are using this final form of the nth term, like 5 power 4 minus k. And again, this is the same thing. If we are given this sigma notation, so how we will find this? So again, we will modify this a bit, and we will change it into this form, like 5 power 3 and 1 over 5 power k minus 1, and then this will be our a1 and this will be our r, and we will put these values in this formula, and we will get the sum of this infinite geometric series. Now we are given in this example the sigma notation of infinite geometric series, k starting from 1 to infinity and 1 over 3 power k plus 1. So this is a bit modified, like k from 1 to infinity and 1 over 3 power k. So 1 over 3 power k plus 1. We will produce k minus 1 over here. How we will produce that? We will subtract minus 2 and then we will add plus 2. So 1 over 3 power k plus 1 minus 2 is k minus 1 plus 2, and 1 over 3 power k minus 1 and multiply by 1 over 3 power 2, and we will write this as 1 over 3 power 2. We will put it like this, 1 over 3 power 2 first and then 1 over 3 power k minus 1. So this series is changed into this 1 over 3 power 2 and 1 over 3 power k minus 1. So a is given as, this is our a1 and this one is our r. Under power k minus 1, this is r. So a1 is 1 over 3 power 2 and r is 1 over 3. So a1 is further simplified, so this is 1 over 9. Putting the values of a1 and r in S infinity is equal to, so this is the formula, and S infinity is equal to A1 is 1 over 9 and R is 1 over 3, so 1 over 9 divide 2 over 3, because 1 minus 1 by 3 is 2 by 3 and 3 1 is 3 and 3 3 are 9, so S infinity is equal to 1 over 3 divided by 2 over 1, and so this 1 will be in the numerator and this 3 will come to denominator. Similarly, in 2 divided by 1, 2 will be in the denominator and this 1 will go to numerator, and the answer is 1 over 6. So 1 over 6 is the sum of this infinite geometric series. But